Saxon Algebra 2, Lesson 4. You guys, this is another like nice, normal size lesson. Breathe deep and enjoy. Our first topic out of, it's really two, is the distributive property. Remember, that is what we do. I'm going to show it to you in weird letters and then I'll actually do problems with it. This is when we say there's a number outside that's being multiplied against a quantity that has addition or subtraction in it. This we could call a binomial, but it's called a quantity because it's inside parentheses and we're multiplying it by the a. The way that we do that is, remember that we have to do two separate multiplications. We multiply the outside times the first thing, then we copy that sign, and then we multiply the outside times the second thing. That's the general pattern that distribution always follows. Now what we're going to do is apply it in a more complicated context, because you know that's for rookies, and see if we can make ourselves lose our minds a little. So we're going to do it with fractions, and we're going to have exponents, and we're going to have negative exponents. Look, isn't that disgusting? Okay, so let me just say a couple of things. Distributing with fractions isn't hard. Everyone just stays on their own level and minds their own business. There's no going up or down. So we'll multiply the 4a across like that, and then we'll multiply the b across, all right? So everybody just stays in their lane is, I guess, the best way to say it, right? The other thing I want to say is that even though we could fix this, like this negative exponents right away, we don't have to. It's not necessary to do that. And we kind of want to get past this idea that we have to get rid of negative exponents right away in all problems. I want you to see that it's okay, they're chill. So what we're going to do is start our multiplying. I'm going to multiply both numerators, then both denominators. Some people like to go top and bottom and then top and bottom. That's fine, however you want to do it. I will mix it up. This time I'm going to go all numerators and then all denominators. So when I multiply these two, I get 4a squared b to the minus 2, right? This times this. Then the minus sign comes in. Then I multiply this times this. I multiply the numbers, 12. I combine the a's. I like to go alphabetically so I don't lose track of things. Here's an a, here's an a. Together, I have 3 a's because that's technically 2, right? And then there's just the one b. So it looks like that. All right? I've done all the numerators. Now I'm ready for the denomies. This one becomes a to the 4th b. And this one is a squared b. Okay, so I use the distributive property to clean that up. Now I have more work to do on these exponents to simplify them because I see a lot of matching bases. I've got a's and b's, a's and b's. So I remember what my rules are. All right, I'm going to remember my exponential, my rules for exponents. And the one that really comes into play here is the quotient rule. Because that's the one that we use when we have a base above and below that matches. And what we can do is subtract the top exponent minus the second exponent. All right, so this is what we need for this next layer of simplification. So I'm going to start here. The 4 is fine. Here's a squared. Here's a to the 4th. So this, if I take 2 minus 4, I get a to the minus 2. Cool, right? If I look at the b's, I get b to the minus 2 minus, this is a 1, right? Minus 1, so this would be b to the minus 3. Interesting, right? Okay, then we subtract. 12 stays the same. Here are matching a's. 3 minus 2 is 1, so I don't need an exponent on that. And then I can put these numbers here if I want. 1 minus 1 is 0. So that means b goes away. Oh, okay. So this is looking like our answer. Now I see the negative exponents in it. I don't know if John's going to show his answer with or without the negative exponents. So at this point, I'm just going to take a glance at the solution and see if John leaves it like this or if he drops them down, right? Does a trapeze swing and drops them down to the denominator. So I take a quick peek and I see, oh yeah, he did. He wrote it like this. He leaves 4 in the top because that's fine, right? And then he writes a squared b to the third as the denominator. I agree, I can do that. And then this is just hanging out in the middle, which you know I hate, but it's right. So this becomes our final answer. Okay? If you would have given me this on a test and I did not tell you how I wanted the answer to look, this would be equally appropriate. Negative exponents are not good or bad, they just are. And it's up to each mathematician to decide if they're useful in that situation or not. So John decided they weren't and he bumped them down, all right? So, and then the other thing I wanted to remind you here is that when we have a base raised to the 0 power, that always equals 1 and it blows up and flies away. All right, so that's why this b, 1 minus 1 equals 0, we could ignore. Okay, let's do another one. So nice to be doing actual algebra, isn't it? Rather than torturing ourselves with spheres and cones. Okay, example 4.2. No, 4.3. Sorry, we already did 4.2. Before I dive into 4.3, I want to remind you of the 3 rules of algebra. This is a great topic for, you know, cocktail parties or mixers that you might happen to be in. You know, if you're doing a little speed dating and you want to come up with a fun topic, 3 rules of algebra will definitely do it. The first 2 relate to equations. The first one says, you can add or subtract any number if you do it to both sides. Okay? And we know we do that all the time, right? Because we want to subtract a 4 to get the x by itself. Well, we just do it to both sides, right? And then we get x equals 2. That's what we're talking about. Adding or subtracting. Here we chose to subtract any number. As long as you do it to both sides, you're good. Second number. Multiply. I'll let you finish copying. This one is almost exactly like the first one. You can multiply or divide. Okay, so we're not adding, subtracting. We're talking about multiplying and dividing any non-zero number if you do it to both sides. I'll tell you why we can't do that, but first let me just show you what I mean. 6x equals 12. We want to divide both sides by 6, don't we? Right, so there we are, we're dividing, and we get x equals 2, and that's perfectly cool, right? What we can't do and I don't know why we would want to do it. Let's just say you wanted to divide this by 0. You can't do that, right? You can't divide by 0 because that blows up the kingdom. So that's why we have to say non-zero. We can't divide by 0. We can multiply things by 0, but we can't divide by 0. So that's why this rule has this special word added to it. These are the two rules that relate to equations. All right, because we're talking about both sides. Well, you have to have an equal sign in order to have both sides. The third rule relates only to expressions, which again is a thing with no equal sign. All right, and in that one, the rule is that I don't know why my brain did this. Whatsoever thou shalt do to the bottom, thou must also do to the top. I don't know why my grammar changed there, but you know this, you do this all the time, right? If we take 3/4 and we want to turn it into something that has an 8 on the bottom, it's fine to multiply it by 2 as long as we do it to the top as well. This is exactly what we're talking about. Whatever we do to the bottom, we have to also do to the top. Or vice versa. Whatever we do to the top, we must also do to the bottom. Okay? So this is the third rule of algebra. It relates to expressions that don't have an equal sign. And there it is. When we solve equations, we're not using this one, but we're using these two all the time. So that's why we reviewed them. Again, they're great to know. Example 4.3. Solve. Okay, as soon as we see the word 12, I was writing down 12 as I said this. As soon as we see the word solve, we know we have an equation on our hands. You can't solve an expression. You can just simplify them. This is long. We have a lot of parentheses, two sets of parentheses in this. So our first step is to eliminate the parentheses. Now, eliminating parentheses means looking at what comes before them and dealing with it. In this one, all we have is a minus sign. What that does is it flips the signs of both of these, right? If you want, you can think of it as it's an invisible -1 being distributed. I think that's a really good way to think of it, right? So 12, this will become -2x minus 5 equals, and now here we have the same thing except it's a positive. So when we multiply this by a +1, it doesn't change anything, right? So when there's a plus sign in front of your parentheses, you could basically just rip them off. If there's a minus sign, you have to do some changing. But this will become -2 plus x minus 3. Okay, so that's a first step in solving an equation like this. The second step is to add like terms. Let's clean this up before we try to swim fish. So I look for matching things. Here I see there's some matching plain numbers. And look, on the other side, we also have matching plain numbers. Now, I'm not swimming anything. I'm only doing housekeeping on each side of the equal sign. So I don't have to worry about that first rule of algebra because I'm not bringing a new number into this. I'm just cleaning up what they've got. 12 minus 5 is 7, minus the 2x, that stays the same, equals -5 plus x. In this case, it just worked out that both of our terms that could be combined were plain number terms. It doesn't have to be that way. That's just a coinky-dink. Now we're ready to swim some fish. And this is where the first rule of algebra comes in. We can add and subtract back and forth as need be. So what I'm going to do is I'm going to add the 2x because I would like that to become positive. And then that means I'll have to swim the plain number fish that way. That cancels, and so I get 12 equals 3x. And then my final step is using the second rule of algebra. We're just going to divide away this so that the x is by itself. Remember, that's always our goal when we're solving equations, is we're trying to get that x by himself on one side of the equal sign and shove all the numbers on the other side. And so we get x equals 4. That's right. Yay! All right. You will not find John talking about swimming fish. Sorry, that's not his jam, but it's mine. Okay, and there's just one more. Oh, these lessons went so fast. I did lessons 3 and 4 together, so I'm just like blown away that I'm getting 2 lessons done in the amount of time that I would not have been able to complete one of our other lessons. One of those long beasticles. Okay, 4.4, ready? Here's what John does to make our lives more rich. Ew. Ew. Ew, John. Ew, that's disgusting. Okay, well, wait, I forgot this. Here's what we're going to do. We're just going to deal with these parentheses, right? That's our first step, eliminate parentheses. So let's just distribute. And then we'll distribute, this is a -1, right? We'll do that. So here we have, I'll put this over 1. Now, I can multiply this and get 15 over 6, or I can cancel and go, oh, that's a 1, that's a 2, right? So when I multiply these two, I'm really getting 5 over 2 minus, and now I'm going to multiply this times this, and I can see, oh, those cancel too. Minus 5 over 1, I'll leave it in fraction form, x, that stays the same, equals -1 times -1/2 is +1/2 minus x. Okay? I don't like these floaty x's, but I'm going to live with them. Okay, I'm going to add 5x. I'm not going to bother to put that 1 on it. I'm going to combine those, and I guess I'll subtract the 1/2 to swim those fishies this way, right? So I distributed. I didn't have any like terms to add, so I got to skip that step. Now I am swimming fishies. These cancel, and I get 4/2, which is also equal to 2, equals 4x, right? -1 plus 5 gives me 4. All right. I'm going to forget about that because I like my answer in that form better, because then when I divide by 4, I get x equals 1/2, right? 2 over 4 reduced. That's the right answer. So don't let the fractions freak you out. Just follow our steps. Eliminate parentheses, add like terms, swim fish, divide. All right? Final answer. Oh, and there's just one more little thing I want. Oh, I guess there's, oh gosh, there are a couple examples to this. This is a handy rule of thumb. When we're doing algebra, we're doing a lot of quick solving. And this is a little rule. Oh, yes. I thought I wrote it wrong. When we are doing algebra, sometimes we can carry some of the work in our head And here's just a couple quick examples of how you can do that. Use the rule, change sides, change signs to solve x minus 2 equals 7. Okay? We could write it out and swim the fish, but we can also do it in our heads. If we want this 2 to change sides, then we know it's going to change signs. So we know that it's going to become a plus 2, and 7 plus 2 is 9. So we can quickly, in our heads, take it to that, right? Because what we're thinking is x equals 7 plus 2. We want it to change sides, so we know it has to change signs. This is just in our brain. Okay, so this is just a nice little thought bubble coming out of our heads. Whose hair is that? I don't even know. This is just a little math student thinking happily about changing sides and signs. There. I don't know who has hair like that. But there it is. All right. So this isn't even a calculation. It's just training your brain to think that way. A fancy name for this idea is transposition. Trans means changing. Position means where it's located. So as we change the sides, we're just transposing. 4-6, use transposition to solve for P. P minus 3x plus 4 equals 7y. Okay, well, we want P to be isolated, so that means these guys have to change. So we can just quickly go P equals positive 3x minus 4y plus, I'm sorry, there's not a y there, plus 7y, right? This is 4. So these guys are changing sides, so we change their signs, and there we have it. That's correct. And example 4.7, solve for y. 3y minus 2x plus 5 equals 0. Okay, this one is a little bit more involved because the y that we're solving for has a coefficient, but still we can do most of this in our heads. We just go 3y equals positive 2x minus 5, and then we quickly divide by 3. So we get y equals 2/3 x minus 5. Looks like a y equals mx plus b problem to me. Is that right? Yes. Oh wait, I forgot the 3. The end. All right, so this is just a quick little rule that helps you do some mental solving so that we don't always have to show every single step. Yay! That's the end of lesson 4. Thank you. Goodbye. I'll video chat with you soon.